Okay guys, so let's look at some of the images found by spherical mirrors. Okay, uh, so we'll talk about ray diagrams. Images found by spherical mirrors. So what are ray diagrams? Ray diagrams are basically a visual representation of how the light is behaving. Okay, so so you guys, we said spherical mirror, right? Okay, so basically what you do is sphere, if I want to draw it into dimension, what happens? It looks like a circle, right, basically. So you have, I actually have a diagram here, so let me show this you guys here. So let's say spherical mirror, there are two types. One is called concave, another is called convex. This is also called diverging mirror. This is also called, this is also called converging mirror, and this is also called diverging mirror. Okay, so but then you may get confused when we get to the lenses. So it's easy, just try to remember just one. Concave mirror, there is also convex mirror. There are two types of mirror. Okay, now let's look at concave spherical mirror. So for concave spherical mirror, how do you form this mirror anyway? Before even I talk about in details about how to draw a diagram, ray diagram. Basically, you have this mirror, sphere, and you take a portion of it, and then that becomes mirror. Okay. So here, if we have a concave, spherical mirror, right? Concave spherical mirror. I have all these, like step-by-step diagram, so I want you guys to draw, but I'm going to draw at least for some of these, okay, so you guys see how to do it. So let's say this is, right now we are just taking a sphere here, okay, so just one sphere of some radius, right, from here all the way to here is some radius, it has some radius r, okay, that's all I'm doing. Nothing else. Okay, so this is a sphere. Now look at this diagram here. Concave spherical mirror. Now if we decide to just take some portion of it, okay, so let's say maybe take a curvature of this mirror, so somewhere just about this part here. Okay, then this becomes a concave spherical mirror. Okay, so we are taking just this part here. See guys, it's blue color there. I don't have a color here. I guess I could just in theory just erase this part, right? And if I erase, this is now concave spherical mirror. Okay, alright, so next step is, so this is the radius of the curvature, right? Radius of the curvature of the concave spherical mirror, that's represented by R. Now if we, so this is the center, right, center of the mirror. So I have a diagram here, so concave spherical mirror, and you see now the new thing here we have is this red dot line. Okay, so that is basically if the line passed through the center of the curvature of this sphere, is concave spherical mirror, then, so guys, make sure you start drawing this with me here. Okay, here like this. In theory I can just make this bigger like this. Okay, so we had our center over here, right? So now this is called, this meets at the center C, and this is called optical axis. Okay, so I'm just drawing this one over here so you guys can see how to draw. picture. Okay, so please make sure take a minute and draw this one. Okay, now there is another thing we want to draw in this picture. Okay, so there is something called a focal point. So here we had this curve, right? We had a optical axis. Now there is something called focal point, this point here. Okay, so maybe I could draw it with different color so you can see better. So let us call this as a focal point here. Okay, that is some F. So I'm going to erase this R because it's going to make my diagram messy. So this is just F, focal point. F means focal point. Okay, so what does this focal point mean? Focal, somewhat it has to do with the focusing, right? Okay, so this focal point, there is a special property for that point. So look at in this diagram, if the light travels parallel to the optical axis, once it touches this mirror, remember mirror, now the light cannot pass through this mirror because mirror is polished, right? It cannot enter, okay? It's not transparent. So the light has to reflect, okay? So this parallel ray of light that is parallel to optical axis, when it touches this concave mirror, it's gonna reflect through this focal point. Okay, this is one of the property. So let's do that. So I'm gonna make this light here parallel, going somewhere over here. It doesn't have to touch with this black dash. Okay, that's just happened to be there. So it's going here, right? Now once it touches this point, it has to reflect back. When it reflects back, it's going to reflect through focal point, okay? So like this. So in essence, you can really make a whole line there, but this is just to show you how to draw it, okay? Alright. So please draw this one. Okay, so now next let's look at the basic guidelines for drawing ray diagram. Okay. Oops. So there are, I'm going to erase this, okay, and we can redraw when we need. Alright, so now there are a few guidelines that would be helpful for drawing ray diagram for mirror. So one of the most, so to locate the image, it's convenient to use 4 rays from the tip of the object. Okay, so now so far we didn't make any object. It will be clear when we draw example. You'll see what it meant. Okay, imagine we have an object. If we had this object sitting in front of concave mirror, then we want to start drawing from the tip of this object. That's what it means. Okay, so now the parallel ray. So one is parallel ray. Parallel ray is drawn parallel to the optical axis, right? So whenever we draw a parallel ray, this ray is reflected through the focal point. We already saw that. Number 2, the focal ray. Okay, so the focal ray drawn through the focal point is reflected parallel to the axis. It's same as the number 1. Okay, so again I'll show this in the diagram also to you guys in a few minutes. So if we have a ray that is drawn through the focal point, that ray must reflect parallel to the optical axis. Okay, number 3, it's about a radial ray. Radial ray drawn through the center of a curvature C strikes the mirror perpendicular to the surface and thus is reflected back on itself. We'll see what does that mean in the example. Number 4, there is central ray. So central ray drawn to the vertex of the mirror is reflected at an equal angle to the axis. Again, we'll also see how to draw this central ray, how to draw this radial ray, and all of this again in the example. Okay, so the key idea is any intersection of any of the two rays can locate the tip of the image. Okay, so look at this. This is the interesting thing here. So intersection of any two rays can locate the tip of the image. Okay, now so let's jump into the example. Okay, so we have so parallel ray, focal ray, radial ray, central ray. All of these rays we are going to draw one by one. Okay, so I have a diagram here already. The concave spherical mirror. Here is an object. This object is easy to make an arrow here, right? You could have just made a tree here, but then it takes longer time to make a tree when you're drawing, so it's just easy to do that arrow. That's why we have that. And then the parallel ray, right? So parallel ray goes parallel to the axis. It touches the mirror and then it reflects through the focal point. This is one important. So I'm going to draw this also, so please you guys also look at here how I am drawing it and then make the diagram. Okay, so we have this our mirror. I'm going to write this name here, concave mirror. Okay, spherical mirror, spherical, it's given. I'm not going to write that down, but this will be fine. Let's make a optical, this mirror has like somewhere center here. So let's make optical axis, right? All the way here. Well, backward is not needed for this one yet. So we'll do. So this is optical axis, right? So I'm not going to write optical axis, okay? I'll just to make a diagram. Let us see, this is our center, this is our focal point F. Okay, now let's say our object is, this is away, right? This is after the center of curvature, so let's make it somewhere around here, this big. Okay, just arrow. Okay, now from the tip of this arrow you want to draw parallel ray. So parallel ray, it is going to go here to get to the mirror. Okay, once it reaches there, you also put an arrow to show the direction it's traveling in that direction. Once it touches there mirror, it has to reflect because it cannot penetrate through the mirror because mirror is polished, right? So it has to reflect back, but when it reflects through the focal point, okay? So it reflects through focal point, okay? Like that. Alright? So we are done with the parallel ray. So I have actual diagram here. If we draw all those parallel ray, focal ray, and then focal ray, radial ray, and central ray, the image form upside down, and it's going to be like this. It may look like, oh my goodness, that seems complicated. No guys, it's not. That's, if you feel complicated, that's why I'm here. Okay, so let's do this. So now let's draw focal ray, right? So the focal ray is basically the one that passes through here. That for that we don't need to really draw it. This ray itself is like our focal ray, right? That's passing through here. Now let's draw radial ray. Okay, so the radial ray is basically, in this case, it's this one here. It's passing through the center of a curvature, and it doesn't reflect back at all. Okay, it reflects back through the same direction, same line. Okay, so if we do that, the radial ray goes through it's kind of like a radius. Okay, easy to remember. So let us say we have like this. Okay, that is our radial ray. Since this goes this way, but it also reflects back through the same path, because it's a radial ray. Okay, now there is also, we said, something called central ray. So in this diagram, the central ray is this orange color diagram here. Okay, so basically this one goes here, and then it touches the vortex of the mirror, and then it reflects back, and it makes the equal angle on this side. Okay, so what does that mean is, let's draw a central ray. So basically we have this light that goes all the way, touches there. Now it forms some angle here, so when it reflects, it is going to make a same amount of angle on this axis, optical axis. Okay, that should be like, it's kind of close, but not what I wanted to do, guys. So let's make this as straight as possible. Okay, so like that. Okay, and then now when it comes back, it's gonna, my hand, sorry guys. So it is going to form almost same angle as this angle. It doesn't look as equal in this diagram, but the idea is to make these two angles equal. Okay, alright, so that is the what ray is this? This is the central ray, right? It goes to the vortex. From the vortex, it reflects back at equal angle. We do have a focal ray here that is going through the focus. So if you guys, we don't have to draw it. We have like enough by now, but we can draw it here. Okay, so if we decide to, I mean, we don't really have to. We already have these two here. That's sufficient. If we want, we can draw this, but we don't have to do it. So if you want, we can draw the focal ray. So focal ray is basically like this. It's kind of, right, it kind of goes through here, and then let's not draw that. Okay, so now you see we have this intersection of this light here, right? My diagram, okay, this one is, it's still not as good as I wanted to make it. This should come here, guys. So let me erase. Let's do it from the beginning. This should be kind of okay. I'm gonna do this quickly here, guys. So this is our C. Let's say this is our F. This is our object. Gray goes here, and then it reflects through this point here. The other ray, goes through the center and it reflects through the same thing, okay? And then there is also another ray that goes like this. This is the central ray, and then it's gonna come back like this basically, okay? So this is what I meant to make. So by the time we have all these intersection here, our image is going to form over here in between C and F. That's what I was trying to do earlier. My angle was a little bit, this angle was bigger, so that's why I didn't have that image, okay? So it kind of looks messy, but if you know the steps, it's okay, we can do it. So this image now is called description. This looks more cleaner than this, so let's look at this. Description, it's called inverted, okay? So if we had an object like this, it's now like this, right? Minified, or it is also called diminished, the size is reduced, and it's also a real image, okay? So actually the light does come to this point, you know, and then they meet the reflected light, they cross at this point, and then it forms a real image, okay? There is something called virtual image we are going to learn in a few minutes, all right? So guys, please take a look at this. If you have to redraw this, just take a minute and then redraw this diagram.